Good afternoon. I'm Mac Lowry from the Getty Museum in Los Angeles. And first off, I'd just like to thank you for the opportunity to attend this Kickstarter. I really am pleased to have the chance to share the origins of the Mount Making Forum with you, but equally really relish the chance to learn more about the work you do here. Looking back at the elements that brought about the Mount Makers Forum, it's become apparent to me that the origins of those elements precede us by quite a bit, actually. In a sense, the forum came about as something passed down through the hands and the efforts of many, who all shared an irrepressible curiosity that was embodied in the anticipation that we can always do better. And I think, for me, this is the thought that delights me most of all, that the mother of invention is really alive and well in the work we do. And every time we imagine a new mount, we have the chance to reinvent and reinvest. And that's exciting. More than 35 years ago, a few of our predecessors at the Getty came to the conclusion that mount making was, at that time, an untapped resource. From the platform of conservation, they perceived mount making as something that could extend the care and control of the conservation studio out into the arena of exhibitions, an often dangerous place, particularly in a seismic region such as where we operate. But the challenge seemed to intrigue them, and the strides they made were huge. Ultimately, this would come to be viewed as a form of preventative conservation, and mount making was incorporated into the various conservation departments in the museum. Perhaps no moment defines the incarnation of this ambition better than the Antiquities Department's acquisition of a collection of statuary fragments of an ancient kouros in the early 1980s. The challenge of reassembling over 800 pounds of stone above two diagonally fractured ankles, all the while ensuring its stability, stretched my department beyond its limits into new territory. The project ended up taking well over a year to complete, and in the process, technology and methods were incorporated from well outside the museum's typical approach to reassembly. In an effort to minimize the holes that would inevitably have to be drilled through those ankles, it was decided to join the major fragments of this statue through post-tensioned cables in an effort to minimize any undue stress that this system might encounter. A base isolator was added underneath the assembly to act as a horizontal shock absorber. The post-tensioning was achieved by securing stainless steel cables into the upper regions of the thighs, swaging them there, and running the cables down through holes that were aligned in the lower portions of the legs, through those ankles and the stone base beneath them, and then out into an aluminum armature that supported them. Post-tensioning is a method used most frequently in concrete slab construction to decrease the chance of cracking and increase strength. Here you can see where the cables come through this aluminum structure and are being held in a measured amount of tension that equals the combined weight of the statue up above. The base isolator, visible down here in blue. Here's a closer look at the configuration of that base isolator. It's a design that was derived from seismic bridge supports and is designed to allow a measured amount of movement between two entities in an assembly that dissipates the force that might come from an earthquake. Here you can see on the lower left the original configuration as it was derived for structures. The columns that would support that structure having a ball bearing at their bottom, which rolled around a bowl-shaped device that was anchored into the foundation. Turning that configuration upside down, here on the lower right, you can see the column is now on the bottom supporting an overpass, and the bowl has been turned upside down and now rides on that bearing. And this was, this was the design that led to the base isolation device that we put underneath the Kouros. You can see in the middle here is a sprung bearing which rides on the interior of this inverted bowl. Up above, the bearings that are arrayed around the perimeter ride on the steel plate that surrounds the sprung bearing. A very effective system for reducing quick movements. And at last, the Kouros on display. This was, of course, a wonderful achievement, but perhaps of more relevance today is less the details of all of that than the model. That being the pursuit of an ideal, a hunt, if you will, for better methods and better results. At the time the Kouros was acquired, the staff that was responsible for its reassembly, care, and display could hardly have known the journey they were about to embark upon, let alone the standards that they would set in doing so. Their work raised the bar for what one could do to make precious and fragile objects available to the public in ways that provided for their safety and stability, in a manner that was all but invisible. To the best of our knowledge, this configuration was the first time that a base isolator had been used in a museum dedicated to protecting a single object. And I'm very happy to say today that we are far from alone now in the use of this method. 15 years ago, you remember this. We don't look like this anymore, do we? B.J. Farrar and I joined the Antiquities Department at the Getty to assume the duties of mount making. I'm not sure either of us realized at the time that we are inheriting over 2 decades of work dedicated to the principle that good enough just isn't. At that time, the department's collective knowledge was buried in this lengthy report authored by 3 seismic engineers, Doctors Agababian, Masri, and Nigbor. They had helped guide the program. We were each given a copy of this and more or less expected to digest its contents and pick up where it left off. I have to admit that a background in fine arts came up a little short at first. But nevertheless, we had joined the hunt, and over the course of the next few years, as we reinstalled the Getty Villa, we were able to develop a basic understanding of these principles and begin to incorporate them into the work we did. Soon after the villa opened in 2006, Jerry Padani, the head of our department, hosted an international conference on the seismic protection of collections. And alongside some very notable seismic engineers and conservation professionals, BJ and I presented a paper on the work that we and our colleagues had done over the years. When the conference was over and we had a moment to reflect, we were both very amazed at the papers that had been given both scholarly and scientifically, but there were very few mount makers in attendance, and those who were seemed as bewildered as inspired by what they had just heard. And it was at this moment that we had our own little moment of inspiration. And it occurred to us that the vast number of mount makers operating in the US and around the world really were operating in a vacuum of silence, unaffiliated silence. And that if mount making really were going to be a vehicle to extend the care and control and protection of objects on display, that in the spirit of a vehicle, we should probably make it move. But that would take the help of many. Taking inspiration from that seismic conference, the thought occurred to us to break that silence with a gathering of every mount maker we could contact and squeeze a commitment from. This resulted in the first Mount Makers Forum at the Getty Villa in 2008. Breaking the silence was our primary goal. The rest we're still working on. At the moment, that amounts to building a structure of networks, knowledge, and standards. I'm happy to say that the networks seem to be flowing. And through the Mount Makers Forums, the collective knowledge of many is starting to take root. Standards remain an elusive goal as we approach this union from so many different areas and angles. But it's our belief that as we grow these networks and build support, that standards will somehow follow. I would be remiss not to reference what for us has been a prime motivator. Next to the threat of bombardment or invading armies, the threat of earthquakes to collections on display is almost unparalleled. These forces show up unannounced at any hour, heaving massive structures around like toys, and quickly, brutally, pointing up any weakness or oversight in design, whether that be of a building or a mount. A brief look down the road behind us is all it takes to recognize these natural forces, but San Francisco in 1906 was such a long time ago, in a different world. Or so we might like to think. But as the road behind points to the road ahead, one thing seems clear, and that is that our future will continue to be one in constant motion. And the origins of that recognition are a lot closer to home than you might think. A look back even further reveals an intriguing link to the Royal Society of London. I'm going to quote from their website. The origins of the Royal Society lie in an invisible college of natural philosophers who began meeting in the mid-1640s to discuss the new philosophy of promoting knowledge of the natural world through observation and experiment, which we now call science. Now, I can hardly attempt to compare the merits of the Mount-Making Forum with those of the Royal Society. But as for an invisible college that seeks to promote knowledge through experiment and observation, I think our origins share some purpose. As it turns out, their first curator of experiments, oh, I love that title, was a man named Robert Hooke, whose early work in the area of deformation dynamics we owe much to. Hooke's law rules that extension or compression of springs is directly proportional to the force that exerted it. This is key to being able to design spring systems. This law is at the core of the dynamics that govern our current base isolator design, which, as you can see, has undergone quite an evolution since what was derived for seismic bridge supports. This model has an interchangeable spring system, I suppose it's obvious, that can be designed per object in order to decrease the ensuing period of an earthquake, taking rapid motion and changing it into a more controlled and gentle type of action. The Chinese must be credited with developing what's widely regarded as the first known instrument to measure and record seismic activity. It's a cauldron of sorts, with an array of dragons in an applique around its perimeter, each dragon having the potential to spit out a metal ball into the mouth of an accompanying frog. Whichever frog ends up receiving the ball indicates the major directional thrust of the quake. Although this cauldron was unparalleled in artistry, poetics, and far ahead of its time, it wasn't until 1880 that another member of the Royal Society, John Milne, developed the world's first accurate seismograph. Due to this work and this device, he's often credited as being the father of seismology, a credit well-deserved, as he spent many, many years in Japan studying earthquakes, which he described as having for breakfast, lunch, and supper. He concluded that terra firma really wasn't so firma, and that it was likely that the Earth's crust was in constant motion. This was a theory that wasn't fully accepted until 1950, now commonly known as plate tectonics. Clearly, your forebears have been busy on these issues for a very long time, and it's a pleasure to be able to recognize their work today and its relevance to our pursuits. Here's one of my favorite bits of engineering history that comes to us as a footnote tacked onto the success of the Otis Elevator Company, who remain the largest international manufacturer of lifts. Their business was anchored in the development of the best fail-safe braking system in the world, which they patented in 1861. It employed a device to lock the elevator in place in case the hoisting ropes failed. And even though that mechanism was rarely needed, having it there in a time of duress was seen to be absolutely essential. In the same spirit, the field of mount making has the potential to provide backup systems like this in the work we do. Not because we're sure they'll ever be needed, and we certainly hope they won't. But under times of duress, what looked redundant yesterday can look very essential today. Duress, of course, is not limited to earthquakes. This 15th century statue of Adam in New York City fell over in 2002 when a support base underneath its pedestal collapsed, resulting in the damage you see here. There's the reassembly and a finite element analysis of every small fractured piece that had to be reassembled. 3 years later, these 3 vases were knocked over and smashed to bits by a visitor walking down the stairs of a local museum here in London. Damage is a hard thing to look at. It's a hard thing to admit. And clearly, we must thank the institutions who own these objects for making this information available to the public. All of these images were pulled from the internet. Certainly, those institutions could never have known what was going to happen. But if we learn anything from hindsight, it's to think like Elijah Otis. Prepare for what you can't control using every means available. I would guess that many of the mount makers in attendance today have considered at one point or another that the better they are at what they do, the less anyone's aware of it. Pardon me. Perhaps, as I have, you've even taken a little bit of pride in that. Today's technological and material advances allow us a range of possibilities to emphasize the beauty and integrity of the objects we care for in ways that can appear effortless. This is, of course, a good thing. But what might appear effortless to some really does take a substantial amount of investment by others. And as our work becomes less visible, we need to become more visible in order to continue to grow the support that's needed to continue these advances. Surely, this discipline, as capable as it is of designing systems to preserve our cultural and historical heritage, is worthy of the growth and development that the Mountmakers Forum provides. Having the Mountmakers Forum hosted here in London would be a giant step towards continuing that. Thank you very much.